Hey everybody, welcome to our tutorial. Welcome to SUSECON 22. We've got a great demo for you today, great tutorial. We're going to be running K3s at the edge, and we're going to be backing the control plane data up to NATS JetStream. This is a new feature and we're excited to share it. Quick overview, we're going to start out by giving a few minutes of just overview about what the solution is, where it's applicable, the components that it takes to run the solution, and then we're going to jump right into the demo. And of course, it's a tutorial you can follow along with at home. We're going to be running K3s clusters at the simulated edge, extending that into the cloud, showing a backup and restore from the cloud back down to the edge, and then showing an example global setup. So a lot to consume here, but it's all interesting stuff, and we're excited to get started. Quick introductions to the speakers. I'm Caleb Lloyd. I'm the Director of Engineering for Software as a Service at Synadia Communications. Synadia is the creator of NATS. NATS, of course, is open source and has many different contributors, but Synadia is a company focused on connecting everything and using NATS to connect everything. So K3s is a great use case to connect using NATS. We're very excited about the NATS JetStream driver, which Matt created. So Matt.
Yep, I'm Matt DeVenny. I'm a Principal Solutions Architect at Boxboat, an IBM company. I've got a background in software engineering. As Caleb said, I'm the author of the integration piece that allows K3s to talk to NATS JetStream.
All right, so a quick overview of the technologies that play here. First, we've got NATS. So NATS, at the most basic level, is a distributed messaging system. So, think PubSub, think streaming. It's really, we like to think of it as a connective fabric. So it can run pretty much everywhere. It can run on, all the way from the edge up to the cloud, secure by default. It shares many of the same project goals that K3s does, which is why we think this integration is so great. And recently, JetStream is been built into NATS, and it's a distributed persistence layer. So a distributed persistence streaming layer that's able to basically do replicated streaming. So capture these streams of messages that we're talking about.
Then K3s is essentially a cut down version of Kubernetes. It's still a certified distribution. It's great for edge computing, but you can deploy it anywhere. I mean, you can run it on your local computer for like a development environment, or you can run it in a data center. It's like I said, it's secure by default. And the great thing that allows this whole integration to take place is that it has a pluggable backend for its control plane storage. So if you're familiar with Kubernetes and you're looking at this diagram, you might see some familiar items called out. But this diagram highlights that K3s essentially takes all of those heavy components and puts them within one process. So K3s server has all the necessary pieces to run the control plane baked into one Go application. And then it includes Kine, which is what allows for its just storage backend.
So can you explain a little more about Kine? Is Kine basically etcd?
Actually, Kine stands for Kine is not etcd. It's essentially a shim for etcd that allows the API server to interact with Kine like it's interacting with etcd, and then Kine translates those API calls into the different drivers that it has available to it. So you can actually back K3s up to SQLite, MySQL, MariaDB, Postgres, etcd if you want to. And now you can back it up to the key value store that NATS has provided with NATS JetStream.
Awesome, and that's hot off the press. So it's actually just been shipped in Kine version 0.9.1. You'll find it in most of the K3s releases in May 2022 and later. We're actually going to be running a release candidate today because that's the only release that it's in. But hopefully by the time you're watching this, there there should be more recent releases of K3s that all support that version of Kine. Just look for that version or higher in the release notes. So for our demo today, we've got a follow along. So it's meant to be a full interactive tutorial. You can try this yourself. And we're going to use retail as an example. So we're going to use a fictional coffee company called Edgy Coffee. They're going to be running their first store, and they're going to back up their store to a distribution center and then mirror their data into the cloud. But as you can see, pretty much any industry you can think of has regional edge locations or local edge locations, and everybody's making use of the cloud these days. So really, this demo is applicable to all kinds of different industries. So here we've got a basic setup that we're going to show, and that's going to be a single distribution center, Chicago, running NATS server, and then we're going to back up a store in New York City that's running K3s. We're going to back that control plane data up to the NATS server in Chicago. Of course, I'm running all of this locally, but JetStream is typically performant up to around 250 millisecond latency. So this would be a supported use case, to go across a country, partway across a country. So let's go ahead and get started. We're going to start by creating a Docker network, since we're going to be running all of these K3s clusters inside of Docker. So we'll create a network for everything in the United States to run. And then we're just going to create a couple aliases here that we'll use to issue Docker compose commands and NATS commands, so we don't have to retype that out every time. We'll bring up the NATS cluster in Chicago, or the NATS server in Chicago. So that's started. Let's go ahead and just check the logs to make sure we're running. Okay, it says server's ready. We've got JetStream enabled here. And then we're just going to issue a NATS account info command. So you can see here, we are connected to NATS. We've got a very low round trip time, obviously, because we're connected locally here, but you'll see it says JetStream is not enabled for that account. The reason for that is we're actually using a hub and spoke model. So I'm on the hub account right now. Each of these K3s clusters is going to be its own spoke account that will have JetStream enabled, and I'm just able to basically view data from each of those. So the first K3s cluster that we're going to create, and that is going to be, we're going to be using K3d to create these. K3d is a project that basically runs K3s inside of a Docker container. That's what's going to enable me to run multiple clusters on my local machine for demo purposes. And the first K3s cluster that we're going to create is going to be in New York City. So I am going to set my location to New York City, and I'm going to run these commands. I'm just going to go ahead and put them all in and start running. And then as each command runs, I'm going to explain what's going on. So the first thing that's happening is K3d cluster is being created. So that K3d cluster setup, we have a file in here, a cluster.yaml file. It's a declarative configuration for this K3s cluster. So this K3s cluster, we've actually got it skinned way down. So we disabled ingress, metrics, or local storage provisioner. I'm really going to be running like a basic container on here that's just publishing to NATS. So I didn't need some of those extra features that K3s ships with by default. And then the part that comes into play as far as backing it to JetStream, you can see here is a data store endpoint argument, and that's going to specify, you can see NATS : / here is the scheme. So that scheme is what tells Kine that we're talking to NATS. And then we've got a URL format. We've got some basic auth here. I just used, the location name as the username and password, and then server name that we're talking to, and the bucket. Finally, this is a JetStream KV bucket. So it's basically a key value store that's stored on top of NATS JetStream, and the bucket name here is the stream name that we're persisting to. So each of these clusters will have a different stream name. If we scroll down here, you can see that exactly US NYC bucket's been created. We've got about a little over 300 kilobytes in there already with 256 kV values. Our K3s cluster has started. So we've got just the basics running on this cluster. It's running core DNS, and then we installed an application onto it, which is just a very simple, single pod deployment. And this is just running an inventory update. It's publishing an inventory update. Every 10 seconds, it publishes an inventory update. It says, hey, this New York City store, and it's picking a random number between 1 and 100 right now to publish, just so that we can see that number change. So this is the Edgy Coffee Company's first store running in New York City, and it's inventory bags of coffee. It's publishing those up to the Chicago distribution center. But of course, this is the Edge, so we want to run more than one cluster. So the Edgy Coffee Company has, opened its next branch. It's got a branch in LA now, and its engineers also want to run Edge workloads at the distribution center in Chicago. So we're going to go ahead and create 2 additional K3s clusters and back them up to the same NATS server running in Chicago. So this script will be running for a couple minutes here, and I think we can kind of talk about some of the next steps here.
Right, so at this point, you might be asking, or you might find the audience asking, like why NATS? Why not run this with HA Postgres, or back it to MySQL? You already know how to manage those, or even why not just use etcd? What's NATS bring to the table that those other guys can't really do for you?
So I think that's a great question, and it's actually one of the first questions we get. But really, you have to think about topologies, I think, when it comes to NATS. NATS is very flexible in what topology it can support. So here we're doing very hierarchical topology. We're going from store to distribution center to cloud. But really, at the end of the day, what we're doing is we're mirroring streams. So KV is getting persisted in order to a stream, and that stream of messages can really be sent anywhere. So it could be sent, to a sibling distribution center. It could be sent to multiple clouds. So it's really more about what you can do with the topologies that is more interesting with NATS.
I think we've also found that in some of these customers we've engaged with, that they're already running NATS on the edge. So adding K3s to that that NATS they're already managing is just a logical extension, giving them less pieces to manage as well.
That's true. That's a good point. So now we're going to talk about extending to the cloud. So some of that, taking a stream and replicating it to a cloud. And what I'm going to do, I'm going to kind of cheat here. So I'm going to use Synadia's global service here, as opposed to like setting up my own simulated cloud. There's many ways to run NATS though, since it is open source. You can take it off the shelf, you can run it highly available, you can run it multi-cloud, but Synadia does have the NGS global service, and that is already a multi-cloud NATS supercluster. So I'm just going to target that. Of course, I've already signed up. I've already imported my credentials. If you're following along, you can go sign up for a free account and try this with NGS if you'd like. But I've already copied all of the appropriate credentials. So pretty much all I have to do is now update my Docker Compose alias and extend NATS into the cloud. So what I did here is I added a configuration to the Chicago NATS server to say, make it extend into the cloud. So that's with a configuration that we call leaf nodes. And that is going to make it so there's still technically 2 separate clusters, right? This is a 1 server cluster here at the distribution center, and this is a separate, cluster in the cloud, but now they can talk to each other. So if I look at the logs, I can now see a bunch of traffic in here. It says we've got a leaf node connection created for the account hub. That's my hub account that's aggregating all three of these K3s clusters. And next, I'm going to start a web app because, of course, when things get into the cloud, a developer inevitably will make a web app to view them. So I've got my Edgy Coffee web app here. I'm going to log into that. I can see, as we stated before, each of these locations is pinging its inventory data every 10 seconds. So after 10 seconds, I can see I've got all of my edge clusters reporting. So I've got Los Angeles, in New York City, both reporting, 13 and 36 bags of coffee. And then Chicago, of course, the distribution center has quite a bit more. I think if we keep this open for long enough, you can actually see these numbers refreshing with other random numbers. So these these messages about inventory are actually following the same path that our K3s control plane data is following. So those messages are flowing up through the distribution center where they can be aggregated. You could run edge analytical workloads on them, and then they're flowing to the cloud. Of course, we want to replicate our control plane data up to the cloud now. So we were going to do that with a NATS feature called mirroring. So that's stream mirroring. And then since my NATS CLI is already connected to my cloud context, I can issue a command to create a stream mirror. I'll issue those 3 commands, and then I should be able to do a stream list. And what I have here is I have asynchronous mirrors. So they're still fast near real time, but they are asynchronous mirrors. Anything that gets written to this distribution center KV store is now getting mirrored over to the cloud. Since it's asynchronous, this distribution center could become disconnected from the internet, say, and still hold its connections to its stores or its K3s cluster that's running at the distribution center. And then once that internet connection comes back online, that stream will pick up mirroring on the last message that it was on. So it's going to be very fault tolerant. So in order to show the fault tolerance here, we're going to actually do a backup restore next. So we're going to completely take offline our distribution center. So let's say, catastrophic failure happened at the distribution center and, that hard drive's gone. It's lost. So we're going to stop the K3s clusters so they don't just sit here and crash loop while we're doing this. But I'm going to destroy the NATS server and the data that's running in Chicago right now. So I ran that. You can see that NATS Chicago volume has been deleted. So that data is now gone. And then what I'm going to do is I'm going to run a backup from our cloud mirrors. So I'll create a new backup. You can see here we've got 3 streams that are being backed up. So we're actually backing up the mirrors. Kind of implementation detail of this playbook is, since what we just did was we copied a mirror, we copied a stream mirror as opposed to a KV bucket. We do have to go delete a particular key that's in this backup file. So that key is called mirror. So we'll just take that out of the JSON file. And again, that's just because we want to restore this as a KV bucket, not as a mirror. So we're just going to remove that metadata about the mirror. All right, great. Those are all gone. And then get back to our instructions. we're going to restore the NATS server in Chicago. So I'll bring that back up. I'm running the NATS server again, but again, there is no data since that data directory was cleared out. So we've restored the server, and the next thing we need to do is copy those backup files over to it. So those are copied. And then finally, we're going to run the stream restore command. We will run that in the appropriate NATS account. Now that those KV buckets have been restored, I should be able to start those K3s servers back up and then go look at my web UI. Got to refresh here. So I don't have anything reporting in right now, but as these containers start again on my clusters, I should be getting inventory data shortly. I can even go look at pods. You can see I had a restart 18 seconds ago, so my app is up and running now. I'm just waiting for that data to propagate through to my dashboard. All right, I've got Chicago back, LA, and New York City. So there we have it. That was a full backup restore from the cloud back down to the distribution center. And then finally, we're going to talk about a global setup. So we're basically going to take the whole thing that we just did in the United States, and we're going to run that in Europe. But I think I've run enough locally myself so while I've been talking here, Matt has actually been following the EU steps in the background, and he has just lit up the EU. So EU is all running on Matt's local computer. We've got Barcelona, Munich, and the distribution center in Luxembourg. So there you have it. We've got 2 distribution centers on 2 different continents, all rolling up multiple K3s clusters, 6 in total, with all of their data backed up to the cloud. Have you had a chance to run the backup stream create command, Matt?
Yep, I'm doing that now.
All right, so we'll check out our stream list, and they're already here. So you can see we've got 6 backups in the cloud now as well. So now to talk about some of the advanced use cases you could do. Complex topologies is one that definitely comes to mind. So that's going to be maybe not doing something that looks as hierarchical, but something that could be, talking to peers. Streams could be disconnected for a long amount of time. You could have the use case where maybe a store needs to back up to a local JetStream, and then whenever that store is online, it can replicate to a distribution center, but it needs to have the capability of running offline.
Migrating cluster is pretty easy. You just issue some stream commands to back up your stream, and then relocate the cluster where you want to relocate it, and issue some commands to restore that stream. And it happens very, very quickly with NATS.
I think if you're running in the same cluster, you can even just use a stream move command, which would make it almost like that would be an online migration. You need to migrate away. So that's an interesting use case too.
Yeah, and then for shadow clusters, the thought here might be that you've got some application running out on the edge. Maybe it's mission critical, or it's in production, and you want to do some troubleshooting but you don't want to disrupt what's going on. So with those same stream commands, you could do like Caleb just mentioned, copy the stream over, and then bring up a new cluster to do some testing with a developer without disrupting what's running out on the edge. So that's an interesting use case that you might have with a shadow cluster.
Yeah, and I think that's actually a great one because one of the biggest issues about running on the edge is you can't always replicate the problems that may be occurring on the edge without, sending somebody down or going in over a very slow connection and doing like a remote terminal. So what if you could just replicate that data and debug it locally? That's a very interesting use case. And then a final one, which we haven't really dug deep into yet, but I know should be possible, is actually pushing configurations. So as opposed to, that cluster always pushing the JetStream data up to the distribution center or up to the cloud, what about dropping a config map, dropping a Kubernetes secret into those clusters from a remote location without kind of routing all the way back through the cluster control plane. We haven't done it yet. We're certainly interested to see what the community comes up with, though, and it's certainly on my short list of things to test with the solution. So we've got this many use cases and more. Interested to see what everyone comes up with. Well, that's it for this session. Thanks for joining our tutorial. You can find us online at NATS.io or email or on the NATS Slack. We're happy to answer any questions and hope to see everybody either online or at the next conference.
All right. Thanks, everybody.